Hello, everyone, and welcome to Nature Connects. Nature Connects is the Massachusetts TNC's webinar series that connects you with scientists, experts, and influencers from New England and around the world. I want to thank everyone for joining us today. I'm Massachusetts State Director and your host, Deb Markowitz. Today, we're going to be talking about nature-based solutions for clean water and climate resilience. And we're going to tell you about some of TNC's innovative new water projects on Cape Cod. We're joined today by Nature Conservancy Massachusetts water team. You'll hear first from Alison Bowden. She leads our rivers, coasts, and oceans programs, and she'll explain how at TNC we've been harnessing the power of nature to improve water quality and build climate resilience. Then our water resource scientist, Sara Burns, and Dr. Katie Castagno, a postdoctoral fellow who's been working with the team for over the past year and a half, will discuss some of the innovative projects they're spearheading on Cape Cod and beyond, and how these out-of-the-box strategies are critical, not just for cleaning up our lakes and ponds, but for tackling climate change. Alison, Sara, and Katie will spend about 20 minutes today talking about their work and why it's important, and then we'll take your questions. As you think of questions, please share them in the Q&A box at the bottom of your screen. Thanks again so much for joining us today, and take it away, Alison.
Thanks, Deb, and hi, everyone. As you know, the Nature Conservancy works to tackle the world's biggest challenges for people and nature. Our global climate is changing. In Massachusetts, the result is that average temperatures are increasing, rain and snowfall patterns are changing, sea level is rising, and we have more intense storm surges. Communities on Cape Cod and across New England are already experiencing these symptoms of climate change firsthand. Heat waves on land, but also at sea, intense droughts like we had this summer, record high tides and flooding, some of which are happening outside right now, and impacts of water pollution worsened by rising temperatures. It's not surprising that lower income communities are bearing the greatest burden. At TNC, we like to think about what a more resilient future could look like. We envision greener cities defended by living shorelines, free-flowing rivers with healthy floodplains that soak up floodwaters, clean water, and healthy ecosystems. Today, we'll talk about some steps we are taking on the path to that future. The Conservancy has three strategies to tackle climate change: mobilizing action to reduce emissions, accelerating the use of natural climate solutions like trees and salt marshes to soak up carbon, strengthening resilience and adaptation to the impacts of climate change in our communities and our ecosystems. Today, we'll talk about how clean water and coastal ecosystems like salt marshes connect to all three. Since we aim to help people and nature adapt, we look to nature for our toolbox. Nature-based solutions refer to practices that use nature to protect public health and the environment. For example, we work to protect or restore natural areas or put in place management practices that will maximize the natural processes that provide flood protection, cleans water, or sequesters carbon. What's great is that these solutions can be applied in rural areas, as well as even in our most dense urban centers. When done right, they not only provide environmental benefits, but they also enhance community safety and save money for towns. The American Society for Civil Engineers gives America's infrastructure an overall score of D+, estimating the cost of repairing public infrastructure at 4.6 trillion with a T, dollars. When we address problems with gray infrastructure, you know, the concrete and pipes we're used to, we tend to focus on only one outcome, often with unintended consequences to other systems or other places. It's like an expensive game of whack-a-mole. Nature-based solutions provide multiple benefits, seeking to address the root of the problem rather than tackling the symptoms. Let me say that again, because we think nature-based solutions are the way to go, because unlike many other engineered solutions, they seek to address the root rather than tackling the symptoms. At TNC, we're working hard to mainstream this approach. So as we work with communities to demonstrate the effectiveness of nature-based solutions, we're creating a track record that will accurately describe their costs and benefits so that key decision makers have the evidence they need to help us scale this approach to meet the challenge. So I'll talk a little bit about a completed project. Many of you have probably heard me talk about this project before. Back in 1921, a Massachusetts state report declared the Mill River, polluted and blocked by dams, dead. Its valued river herring run gone forever. In 2005, this dam made national news after days of heavy rain threatened to break the dam and flood downtown Taunton. 2,000 people were evacuated. Fast forward 15 years, after lots of hard work, 3 dams removed, 1 rebuilt with a fishway. The river is cleaner and it's very much alive. 7,000 river herring returned this year. The base flood elevation is lower. The risk of flooding to the city's residents is greatly reduced. We made the cover of a national report on the economic, social, and environmental benefits of dam removal. With the help of updated regulations, new funding, and new science for which TNC has been a key advocate, more than 60 dams have been removed across the state. Dam removal is a nature-based solution that has become mainstream. Thinking big and tying this work to efforts up and down the Atlantic coast is paying off here at home. Massachusetts saw its highest river herring returns in 3 decades in 2019. We're also working across New England to demonstrate performance of coastal nature-based solutions to address erosion and flood risk. As we advance the use of more engineered solutions like constructed salt marshes, it's critical to think about the conditions that support them and the natural marshes and seagrass beds we rely on so much. I'm going to turn it over to Katie to talk about what salt marshes do for us and describe the Herring River Restoration Project. Katie is wrapping up her fellowship with us and starting an exciting new job focused on the cutting edge science happening out there. Over to you, Katie.
Thanks so much, Allison. As we've seen, nature-based solutions often seek to maximize ecosystem services, which are the benefits that natural systems can provide. Especially on Cape Cod, salt marshes provide numerous benefits. They provide critical fish and bird habitat, beautiful vistas, and like in this picture, fun places to chase fiddler crabs. Coastal wetland ecosystems provide a trifecta of climate wins. They capture carbon at rates up to 5 times greater than terrestrial forests. They provide sea level rise mitigation, and they also provide increased coastal resiliency to storms and flooding. Understanding and quantifying these ecosystem services and how they change climate risks will be especially important for applying this information in ways that insurance and other risk assessors can use. Approximately 50% of the world's population lives in coastal areas, so they're exposed to increasingly frequent and more severe sea level rise and flooding risk. An estimated 50% of the world's mangroves and seagrass meadows and at least 25% of tidal marshes have been lost from conversion for development and natural degradation. Here we can see the amount of salt marsh lost in Greater Boston over 2 centuries. Here we see an example of how salt marsh vegetation can provide storm protection to coastal communities by reducing wave heights during storms. A degraded or restricted marsh does not have sufficient vegetation to reduce wave heights, and coastal communities are more vulnerable to storms. On the right, we can see an example of how a healthy marsh on the top can sequester carbon. When the marsh is drained or restricted below, we see more carbon emissions from the marsh. This increases the level of greenhouse gases in the atmosphere. When marshes are damaged or destroyed, we lose all the benefits a healthy marsh provides. It's estimated that restoring just 25% of lost coastal habitat would add an annual capture of 350 million tons of carbon emissions, prevent the release of a further 80 million tons of carbon, and improve flood damage mitigation by up to 29% globally. TNC is exploring the opportunity to structure a blue carbon venture fund, which would identify and develop projects around the world that could restore and/or protect these important coastal ecosystems. On Cape Cod, work is being done to restore degraded salt marshes to reclaim their previous ecosystem services. In 1908, a dike was built on the Herring River in Wellfleet, Massachusetts, to reduce tidal flow and an attempt to reduce mosquito populations and increase arable land. What was once a thriving 1,000-acre marsh slowly deteriorated. In the 1980s, a series of fish kills drew attention to the water quality issues in the estuary, largely due to the increased anoxia and acidity in the water above the restriction. The Herring River Restoration Project will be the largest restoration project on the East Coast, involving installing new tide gates to restore tidal flows to the estuary. The project is currently in the early stages of permitting, led by a great team of federal, state, and NGO partners. We've already seen that restoration of tidal flow to the system can quickly restore ecosystem services. In the 1960s, the original tide gates deteriorated. By 1968, the gates had rusted open, leading to improved salinity and tidal flushing. And shellfish quickly recolonized the area above the restriction. In the 1970s, and this will be a few slides back, the tide gate was rebuilt and the shellfish population disappeared. But so in addition to improving water quality and restoring native vegetation for habitat and fish, habitat for fish and wildlife, restoration of the Herring River will increase the system's resilience to hurricanes and winter storms, which will in turn increase coastal protection. A TNC study found that wetlands regionally prevented $625 million in direct flood damages from Hurricane Sandy. Here on the left, we're looking at an example from Hurricanes Katrina and Rita in 2005. Even though both storms had made landfall at similar intensities, Hurricane Rita had to travel over 30 to 50 kilometers of wetland before reaching a populated city. As a result, its surge was significantly reduced, and its impact on coastal cities was far less destructive than that of Hurricane Katrina. This is particularly important as climate models predict that tropical cyclones will become more intense with climate change. This year, we saw an unprecedented 29 named storm to the Atlantic, and coastal protection is more important than ever. The Herring River Restoration Project on Cape Cod, as the largest restoration project on the East Coast, would also generate greenhouse gas benefits by reducing methane emissions and increasing sequestration of carbon dioxide in restored marsh soils. For blue carbon especially, these benefits have potential to be monetized. A recent report shows that a moderate estimate of carbon offsets generated by the project over an initial 40-year crediting period is approximately 85,000 metric tons of CO2, and could be as high as 300,000 metric tons. Development of projects like the Herring River Restoration Project and others in the voluntary market will provide needed evidence that the ecosystem service benefits from these types of innovative projects can be reliably quantified and included in regulatory programs in the future. And now here we'll all head over to Sara Burns to talk about how clean water can fit in.
Thanks, Katie. Could you go back one slide for me, please? Thank you. So we've been working on Cape Cod for years as part of a team thinking about nature-based solutions and how to get to scale for water quality. And on Cape, we're specifically thinking about nitrogen pollution. As many of you might be aware, Cape Cod has a nitrogen pollution problem. In 2011, a lawsuit by the Conservation Law Foundation spurred a watershed management planning effort for the cities and towns on Cape Cod, led by the Cape Cod Commission, which is the regional planning agency for the Cape. This effort developed pollution diets, or they're sometimes called total maximum daily loads, to set limits for the amount of nitrogen allowed in most of the coastal watersheds on Cape Cod. So we're focusing now on Cape Cod, but the problem is not unique to Cape Cod. In fact, as the quote on the last slide indicates from Yale Environment 360, we must have the amount of nitrogen that we dump into the environment by mid-century or face epidemics of toxic tides, lifeless rivers, and dead oceans. So you can stay on this slide for now. So as I mentioned, the work on Cape Cod to reduce nitrogen pollution is happening under this regulatory umbrella, and it's about total maximum daily loads or pollution diets. And those are all tied to the amount of nitrogen that we need to get back to support seagrass beds, which is what's pictured here on the left, versus what we see on the right, which is when we have too much nitrogen. And so when we have too much nitrogen in the system, a lot of things change besides the seagrass beds. We can also see degradation and loss of the important salt marshes that Katie was just talking about, and release of stored carbon and the loss of future carbon sequestration potential, both in salt marshes and in these seagrass systems. This algae on the right, I don't know if you've ever been around it, but it's kind of stinky and slimy and sometimes toxic. And so that's another impact of nitrogen pollution. We also see coastal acidification, loss of oxygen or anoxia that Katie mentioned earlier, which leads to fish kills and shellfish kills. And on Cape Cod, where all of the drinking water comes from one groundwater aquifer, we're risking drinking water pollution as well. So the big takeaway here is that excessive nitrogen fundamentally changes our coastal ecosystems, and the systems that they change to don't have the same complexity or provide the same services as the historic ecosystems. And to Alison's frame right at the beginning, climate change is kind of exacerbating this harm, which we want to keep in mind as well. So this is the picture of nitrogen polluted coastal waters. And as you can imagine, the changes in the ecosystem that's represented by this slide also pose economic threats to Cape Cod communities, including potential losses of tourism, declining property values, and declining fisheries. On Cape Cod, thanks to the planning efforts led by the Commission, we know that about 80% of the excess nitrogen comes from perfectly legal, functioning septic systems. And it is estimated that only about half of the homes that have these systems will be economically feasible to sewer due to low housing densities on the Cape. So we are working with an amazing team of partners on exploring nature-based solutions to manage wastewater in the town of Barnstable. I'm going to focus today on one solution, but we've really taken a watershed scale approach to this, led by the Barnstable Clean Water Coalition, to really think about the role for things like restoring cranberry bogs to natural wetlands and other practices can have on this watershed. But again, today I'm going to focus on what's represented here in this slide, which is a wood chip based septic system. So we refer to these as enhanced septic systems, or the second generation of enhanced septic systems. And the nature-based part of these systems is that they rely on wood chips as food for bacteria. And those bacteria transform the nitrogen that's coming out of our homes and our sewage back to a gaseous form that is no longer available for plants to grow. So it's removing the nitrogen, the load of the nitrogen from the system, rather than just shifting the problem around to a different location. In this partnership, what we're focusing on as the Nature Conservancy is leading the effort to think about how to break out of the model of relying on grants and philanthropy, which are limited for projects like this for a number of reasons, and to work at the scale of municipal wastewater management and hopefully harness the power of private investors to really bring these promising nature-based solutions to bear on the problem. So as I mentioned, we're working with the town of Barnstable as we are particularly thinking about these innovative septic systems. We're thinking a lot about the plan that Barnstable currently have, which is what's represented on this slide. So the town is working through the process of getting approval for a 30-year, $1.1 billion plan to construct sewers and bring excess waste from these homes to their wastewater treatment plant. We know the white areas on the map are the part of town that aren't planned for any sewer treatment. And some of the areas in yellow on this map are in the sort of later phases of that 30-year plan. And we know that these areas are more expensive for sewer installation. Now, the town has a placeholder in the plan that they're working on for nature-based approaches, but how those are actually going to slot in is something that we're trying to actively work on. And we know that new approaches are risky, especially for municipal government. So our partnership is working in phases to test the technology and document performance, and to think about how to structure subsequent phases to grow and to fit into the portions of the town's plan where sewers might not be the most financially feasible. We do not want to supplant all of the sewers with these systems. We're trying to be realistic about where sewers really are the most cost-effective way to solve the problem. We're just trying to help fill in some of the gaps. And we are also trying to think about how innovative finance and innovative management approaches for these systems can help minimize risk to the town. So this slide is a cost benefit estimate that we worked on a few years ago. And as we continue working on experimental pilots to build these systems, we are definitely refining these numbers. But I wanted to share them with you to give you a sense of how we're thinking about approaching this project. So the cost estimates here come from the life cycle costs of system purchase and installation, and then also 7 years of costs for operations and maintenance and regulatory compliance for these systems. So based on those costs, it costs about $300 to $400 to remove 1 kilogram of nitrogen, which is sort of the unit we're using to compare these different technologies. How much is it to remove 1 kilogram of nitrogen? And in the project that we're envisioning, we think 225 systems could be an annual reduction of about 1,000 or 1,400 kilograms of nitrogen. And that would represent a saving to the town between 11.6 and 15.7 million, just offsetting, that amount of nitrogen needed to be sewered. So as I said, this is a first approach at this, and we definitely plan to refine it as we get more data from our pilots. But this cost information is relevant to the town so that they can really compare these different technologies. And we hope will also be motivating to potential impact investors. And we're thinking about impact investors because they are private investors who expect that markets can work for environmental return as well as for capital. And we hope that by partnering with innovative investors like this, we can think about upfront capital to help meet regulatory goals faster, pay for performance and environmental outcomes, and to help spread the risk to the town of trying these innovative solutions with a broader market. And that is all I'm going to say today. So thank you.
Sara, that was really fabulous. And all of the speakers, really interesting work. Thank you so much for sharing with us today. We're going to be moving into the question and answer portion of the webinar. Just as a reminder, if you think of a question for the team, please share them in the Q&A box at the bottom of your screen. And I noticed that a couple of participants raised their hands. Again, if you want to ask a question, we're not doing questions live. You need to write them into the Q&A box so we can make sure that we're catching every question we can. So to start us off, are these projects we're piloting scalable? Is your hope that one day these solutions can be scaled so all communities where clean water is threatened can have a safe and clean drinking water? So that's really, for Sara, thinking about your work.
Yes, it's a great question, and the problem definitely exists at scale. So similar to Cape Cod, the Long Island Sound, it has the same nitrogen pollution problem and the same driver being septic systems. This is a problem in Florida and in Hawaii. And in fact, EPA estimates that about 20% of wastewater in the United States is handled by on-site systems. So absolutely.
So there's a need. It's always more challenging when the solutions are house by house, as opposed to, putting in place a system of pipes that, to a central spot. So one of the things that I'm so excited about this project is that it's about looking at alternative financing models to, how do you scale with money? I'm wondering if, Alison, we've got a question about how is climate change impacting our ability to provide clean water? I assume this is the right question for you as the head of this.
Absolutely. Yeah. Thanks, Deb. That's a great question. And in short, climate change is impacting our ability to do everything. But in particular, where this summer we had a really intense drought, my water supply reservoir didn't have any water going into it for several months. So that's an impact of climate change on providing water. And as I mentioned at the top, even if our pollution diet stayed the same, increasing temperatures would actually make the impacts of that pollution worse. And so we really need to put ourselves on that diet and dial back what we're putting into the system and start to reverse the impacts that we're already seeing.
That's helpful. We also have a question. Why are there particular challenges on Cape Cod? You know, is there something unique about Cape Cod?
Well, would you like me to go first, Alison?
Sure.
It's a great question. Cape Cod is very sandy, which gets cited sometimes as part of the problem. But in reality, these Tidal V systems are releasing nitrogen in any soil. So part of the focus on Cape Cod, I think, has to do with the fact that there was this regulatory pressure to come up with new plans to deal with the being compliant with the Clean Water Act. So there was a big push, I think, in part because the watersheds were really starting to suffer. And then I think that another thing that makes the solution set really unique on Cape Cod is that the housing density is really low. So installing these pipes and hooking up to get to a wastewater treatment plant can be really, really expensive on a per house basis. There just aren't enough people to support that as a financially viable option. So they have a problem. They have a regulatory framework that says you need to solve it, and they know that the traditional solution is going to be cost prohibitive for maybe as many as half of the homes. So I think it's kind of a combo of all three.
Interesting. So there's kind of a question that might work well as a follow-up. Someone asked, beyond attracting private capital to the nitrogen problem, with what tax or financial incentives would you like to see to encourage private landowners to upgrade septic systems to get to a scale of septic systems at which there could be meaningful positive impact? I think that's a great question.
It is a great question.
Do we have an answer to it?
Sara does.
Yay.
So one of the things that we're focusing on early on, and I think this is an important point to make, is that the second generation of innovative septic systems is still only allowed with provisional permitting status because we haven't tested enough of them on actual homes. So that's an important first hurdle we need to get over so that anyone can install them without doing anything extra, right, compared to a regular septic system. And then the towns are thinking creatively about this. So we have already regulations about that when you transfer title, you have to have a functioning septic system. So there's a potential to think about tweaking that a little bit to say that when you're in a nitrogen sensitive area, you need a nitrogen sensitive septic system. And then I guess also the state has the state revolving fund, which is an existing loan program that can go to septic systems. And so once we get past our sort of accessibility hurdle, we hope to be able to tap those funds as well. And there's lots of people are thinking about this, but those are two examples.
That's great. There was another question from somebody else who said, couldn't the town of Barnstable simply require that any new house construction use one of these wood chip denitrifying systems instead of the conventional septic system? And, as a practical matter, we prove, what we do at TNC is we prove we prove the science, we prove that it works. We help think about how to make it affordable with the idea that ultimately it gets scaled through regulation as one tool. So yes, and I'm sorry for the lights going on and off. We're having, it's a storm. So thank goodness my computer's not plugged in, so I didn't lose you when the electric went off and now it's back on. So let's see, we've got lots of questions about this project. Somebody asked, can the wood chip based system have make similar improvement for lakes and ponds, say in New Hampshire? And, folks may not know, but when we're thinking about water pollution, in coastal areas, the pollutant of note is nitrogen in saltwater systems. The pollutant of note in freshwater systems is often phosphorus. So will this help with phosphorus problems also?
So the wood chip systems don't do as much for phosphorus as they do for nitrogen. We are learning in some of the work, because there's plenty of sensitive kettle hole ponds on Cape Cod as well, that at a certain point, the phosphorus may just be recirculating in the pond, and reducing the nitrogen might actually also help, is what we're learning with our science partners at EPA's Office of Research and Development. So maybe, but you would also need to deal with your phosphorus problem. But these wood chips also get built in trenches along barriers of water bodies. They call those permeable reactive barriers, but it's the same thing, and it does act as a wall for the groundwater to move through before it gets to a lake or a pond.
That's great. So another question came in on this: is there a way to harvest the fixed nitrogen, and in parentheses ammonia, instead of converting it to N2, given that it is energetically expensive to fix nitrogen in the first place? That's a very technical question. Like, what are they asking to?
Oh gosh, okay, that is a technical question. So the nitrogen, the Deer Island wastewater treatment plant that treats the waste from Boston does that. Part of how they handle the nitrogen is they capture some of it and they make fertilizer out of it. So that is something that's technically possible. I'm not sure that we haven't explored that for these septic systems, but potentially the load that goes to the sewer could explore something like that. I don't know, Allison, if you want to add to that.
I don't think I can add to that. I would add one quick point on the question about phosphorus, that another thing we're looking at is contaminants of emerging concern. So that's things like pharmaceuticals and things that there's sort of not that much known about them. That's why we call it emerging concern. But there's getting to be more and more evidence that we should be really concerned about them. And septic systems, the septic systems that we're looking at, we're interested in this question of how much they can help with that, which is really important when you have a sole source aquifer. So that's another piece of the puzzle.
That is interesting. I know in EPA, when I was environmental secretary in Vermont, we were really looking at the PFAS chemicals, which are these forever chemicals. We have, and we think they're endocrine disruptors, and they stay forever in our system. And so the question then becomes, is there a way to keep them from getting back into the aquifers or into our drinking water? So yeah, really, really important, in addition to pharmaceuticals. I mean, everyone's heard stories about the bay having, estrogen in it or whatever it is. And what does that do to our sea life? What does it do to us and our kids? Those are all really important questions. Let's switch for a minute to salt marsh. We've got a question. Does TNC have any management plans for upslope assisted migration or restoration of salt marsh grass in the face of climate change? Any thoughts on this?
I can take that one. So that's an incredibly important question. We've done some work on the entire coast, looking at where the best places are that salt marshes might be able to migrate. Our New Hampshire program in Great Bay has been focused on that for a number of years, protecting land, up against salt marshes to help them migrate. And that's something that we're looking at and really interested in here in Massachusetts and up and down the coast. What are the best options going to be as the climate changes? We're developing a project now with the Mystic River Watershed Association in Boston, actually looking at that question. So much more to come on that.
Another interesting question is, do we venture into biomimicry? And it might be helpful to say what this is, and how is that the same or different than nature-based solutions?
I'm not sure I know what it refers to. Katie or Sarah?
I can take a stab. I believe it's the idea that you bring in like biology and like ratios and green things into design for built environments. Like I think it's something that architects do. Okay. The nature-based solutions is a hugely broad umbrella. We haven't focused on the built environment design as part of nature-based solutions, but I will say that where there is crossover, I think, is thinking about things like green stormwater management and bringing vegetation into our dense urban areas. And that has some of the same benefits that we see in biomimicry. It's getting people around plants and around green things. So I would say that they're related, but we haven't specifically focused on biomimicry yet.
Nice. Can we comment on any marine permaculture projects in the Cape Cod area? So it's, you know, going further out, right?
I'm not totally sure what marine permaculture refers to. So I'll take aquaculture, that we are working really significantly with growers, which is also a really huge issue on Cape Cod. We have a program in response to the pandemic, working with growers to buy back the oysters that they haven't been able to sell and plant those out on restoration sites. So we have 4 sites in Buzzards Bay that will be completed before the new year. And that's a program that's in partnership with 6 other states on both the East and West coasts. So we're really excited about that work. And there's a lot of potential for things like seaweed and other kinds of aquaculture. Our current focus is on shellfish. So hopefully that moves in the direction of answering the question.
Yeah, no, that's helpful. We have so many questions. I have to say, we've got 35 questions still in the chat. So so I'm gonna try to pick and choose so that we hit a variety of things. There is a good question. Can I ask the presenters how the local communities are firstly engaged and then involved actively to create acceptance and then ownership of your project?
Well, that's a great question. Katie, do you have anything you'd like to say about Wellfleet, since you're living out there now?
For sure, for sure. I mean, and this kind of gets to, I think I see another question in the chat too about kind of the lessons learned from the Herring River Restoration Project. And I think one of the biggest challenges for the restoration project is really that it's been something that's been in place and in the works. People have been talking about it for decades now. And it's really kind of, it's come into really kind of having to really deal with the stakeholders and really kind of make sure that, you know, abutters are happy, make sure that the public really have their concerns addressed, whether that's through public meetings or like the Wellfleet Harbor, State of the Wellfleet Harbor Conference, which this year was online. It was great. You could just pop in on YouTube. But a lot of it is really just kind of talking to folks and really trying to get at what concerns are and how we can fix them. So like the postdoc that I'm going to be starting in a few weeks now is looking specifically at sediment transport in the Herring River, because shell fishermen are really concerned about, with the restoration, will there be a lot of sediment that will come and be deposited on their shellfish beds. So part of my job is really kind of looking at and addressing that concern for the shell fishermen and making sure that their beds will be all right.
Thank you. A couple of questions about the impact investing. Somebody asks, can you say more about the impact investing approach? How does the septic project generate investment returns? And then the second question is, are there private investors interested in this project? I'm not clear on the benefits to investors in this or how they get returns on capital investments.
Yep, those are good questions. So, you know, as we're thinking about approaching the septic systems, we've thought about this from a few angles. One that I think is easiest to talk about is thinking about it from the perception of the town. So if they're willing to spend capital on a sewer system, could we structure a deal that clearly demonstrates significant cost savings to them, even with a slight return for impact investors over what it would cost to handle the same amount of nitrogen by sewer? So that's a very simple way of thinking about it. But the avoided costs, we think are fairly powerful with this solution. We haven't really courted investors, but we have been approached by a few people who have said, when you're ready, I think that my firm would be interested in this. So preliminarily, yes, we're getting feedback that it would be appealing, especially to like private wealth investment managers where the family lives on Cape Cod. There's a lot of, actually, to the earlier question, the citizens on Cape Cod are very aware of this problem.
Sarah, do you want to say something super quick about the stormwater ones that exist?
Oh, sure. Yeah. Yes. So as we've been working on impact investment, we've had support from NatureVest, which is like a branch of the Nature Conservancy that specifically focuses on impact investment. And they have stood up a couple of deals in America and around the world where you develop an investment market to pay for stormwater management. Yeah, and there's a little bit of return that's generated. Sorry, I didn't think through that one. But yes, we have a few examples that exist already, and you can Google NatureVest and see all their great work.
Let's see, I'm trying to pick and choose, so bear with me as I'm coming through the questions, because I want to try to cover things, not just sticking on one topic. Here's a question. What are some of the lessons to be learned from the Herring River Coastal Salt Marsh Restoration Project on Cape Cod? And is it applicable to other coastal salt marsh restoration projects?
Sure, I can take that one. So as we kind of talked about before, again, kind of getting at the kind of the biggest issue that I think the biggest kind of struggle that the Herring River Restoration Project has had is really trying to get that public support. And I think that the lessons learned in the Herring River Restoration Project, whether in really kind of trying to address all of the concerns of the stakeholders and the abutters is really important. And that's the sort of thing that we really need to do to create kind of a greater acceptance or support for marsh restoration projects. It's interesting because in this case, it's almost like because the project construction hasn't really started yet. We get to, like, this project will now get to use the lessons learned from all the other salt marsh restoration projects in New England. So it's great because it all works together, right?
Yeah. So here's another really good question for us. From a scale and coordination perspective, how is the Nature Conservancy working to make climate solutions more broad scale and more effective, as opposed to winding up with these smaller scale random acts of climate solution kindness? I like that idea. We're doing lots of little projects, and how do we take them and make them a scaled solution?
Deb, why don't you start with that one?
Well, this is how TNC works. We have one of the reasons why I love TNC so much is we're this global organization. So we're thinking about science at scale, thinking about the whole planet. And then we do projects on the ground with it, where we test things out, we try solutions, we think about finances, we think about best practices and community engagement, and then we scale it in a couple ways. One, we do it through regulation, right? We have a really good policy arm where we think about how do we embed this into our regulatory frameworks, our funding frameworks, our building codes, whatever it is. And we also then give that science back to this global organization so it could be scaled around the world. And it really makes TNC such a powerful organization. Thinking globally, really developing this really powerful science, and then by doing projects on the ground, but then scaling it. And so this is a great example. All of these projects we talked about, from the dam removal and what it does, the marsh grasses, working on septic systems. Believe it, septic systems are a problem around the world. So what we learn in our science, we really can make happen. So how's that, Alison? Did that do the trick?
That was great. I'll add one thing, and that's that we're really strongly networked. So the sort of the mechanism for what Deb was talking about, I was on the phone yesterday with the global risk and resilience lead. Katie's support team, research collaboration team includes someone from the University of California, Santa Cruz, someone in the Gulf of Mexico, and that position is shared with Northeastern University. So we have really powerful networks that support those connections. It's a very deliberate set of, we aim here in Massachusetts to do things that are directly relevant to advancing the field whether the field is climate resilience or climate, carbon sequestration or anything else. We're really looking at the field of science and how we can move that forward, move the strategies forward, demonstrate things here that will be relevant around the world. Tonight, my colleague Stephanie Weir is doing a webinar about a similar topic in Hawaii that I'll be on. So we're learning from each other that way.
Yeah, that's really one of the really fun things about being part of TNC is we've got these colleagues doing incredible work all around the world to learn from, to share with. So we have a whole bunch of very specific questions about the septic, what we're doing with septic systems. So I'm going to just do a few of them, bundle them a little bit for us. And it may tell us that that there really is the thirst for information. What can septic system owners do right now as they await sewer extension? Is there an increase in nitrogen in the groundwater from septic system discharges that require additional treatment prior to its use? What would it cost an individual to enhance their septic system now? And how much do you hope it'll be reduced to once we scale the program? Let's see. Why don't we start there?
Okay. I'm gonna have to write these down.
There's a whole bunch of people who are on who have septic systems, and the other good one that's hidden up here somewhere is, how do I know if my septic system is leaking? And is that really the source of the nitrogen problem, or are there other sources as well?
Yeah, okay, so that's a lot, but those are all great questions. So maybe to start at the end, actually, the way that nitrogen works always is that when it's in its like nitrate or ammonium, like the form that it comes out of our sewage in, it has the way that it's structured is that it does not bind to our soils. So a lot of it does just keep moving through the soils. So that is one part of the answer. On the Cape and in Long Island, we know that septic systems are the primary source of the nitrogen pollution. But like if you look at the Gulf of Mexico, where they also have a big dead zone that's driven by fertilizers, that's coming from agricultural fertilizers. So the ultimate source of the problem kind of depends like what scale you're working on. But for us on the Cape and in Long Island, it is septic systems. Yes, that nitrogen also is getting in our drinking water. Right now, nitrogen is only regulated for our drinking water based on one particular syndrome that I never say correctly, but it's colloquially known as blue baby syndrome. The threshold for that is very high. And that means like you can have a lot of nitrogen relative to what we're seeing in your groundwater before anyone will say, oh, you need to regulate that. We do see places that are approaching that threshold. And there is some evidence that there are other health effects that happen at a lower concentration. So that is also kind of a complicated answer. So it depends. Right now, not very many people have to pull nitrogen out of their drinking water. Generally, I think most of the regulation is trying to get it out of our wastewater. How can anyone get it? So these systems right now, the ones that we're working on, reduce the nitrogen really, really well. Like well, I won't go down that path, but they work really well. There aren't that many of them in the ground. So if you want one, you need to coordinate probably with your local board of health, and to understand you need to get a bunch of regulatory approval to do it. And there's a monitoring requirement. So one way to do it is to go to your local board of health. Another way to do it maybe would be to go to a watershed association and see if they're doing grant programs. That might be a follow-up email, really.
That's great.
What did I miss?
So there's another specific question. So in the wood chip septics, do the wood chips deteriorate, decay, and need to be replaced? So there's the cost of putting it in, but then there's the maintenance.
Yes. Oh yeah, and that was another question too. Right now, the sort of add-on, the wood chip add-on for the systems that we're working on is about $15,000, and the cost to really install one depends. Like Does your tank still work? Is your leach field still good? So that's the base cost. We do hope that will go down. We don't know exactly how low yet. And the wood chips, there is some rate of decay, but so the way the chemistry works, you have to move the waste into an area where there's no oxygen for it to be in the form that the bacteria want it to be in. And because there's no oxygen, the decay of the wood chips is really, really, really slowed. So we don't know how long they'll last, but the rates seem like maybe more than 30, more than 50 years. So at some point, yes, you would have to change it, but it's not burning up.
Yeah, that's great. That's really great. So we got two questions that I want to put together. The question came in, I imagine there's synergetic effects from prevention of nitrogen pollution and coastal restoration. And somebody also asked about the use of oyster shells and whether or not oyster shells also can help with nitrogen reduction.
Yes. So nitrogen pollution right now, I would say, is the limiting disruption to getting our seagrass beds back, which doesn't mean if we turn it off, they'll just come back immediately. But yes, and nitrogen pollution also can throw off the balance of salt marshes and make them weaker, make the plants fall over. It's a problem. And the oyster shells, I think, are helpful maybe in growing new oysters, but the chemistry coming off the oyster shells doesn't really mitigate the nitrogen problem. The nitrogen can make our coastal waters more acidic, though, like coastal acidification. The chemistry of the oyster shells could maybe offset that, but that's not something that I actually can really speak to. We aren't studying that.
Yeah.
Alison, I don't know if you want to add to that.
Well, the coastal acidification is a significant concern for aquaculture. There's also some indication that aquaculture, in particular seaweeds, could provide some help, particularly at the scale of a bay, help with that buffering of the acidification. That's obviously a really big systemic issue. But I think that's about the limits of my knowledge on that question.
So to pivot just a little bit, there's a question, how has our work been impacted by the pandemic?
You want to start with that one, Katie?
Sure. Just generally in terms of field work, it's a lot harder. And I know that a lot of the work that I've been doing with TNC had been involving interviewing folks to ask them about different nature-based solutions and on the Cape and also in the Boston area. And that also becomes a lot more challenging when normally you could kind of meet up with somebody over coffee or even meet them at the site and they could give you a site tour and it would be really great. But we do what we can in terms of making it work with Zoom and talking to people on the phone. And, in the summer, we could even go out and do a social distance kind of site tour if we could. So it's definitely been a challenge, but I think we've adapted the best we can.
Yeah, I would add that we are so fortunate to be able to do our work from the comfort of our homes, and to be able to, I say wherever my brain and hopefully my computer are, I can work and be productive. And I'm so grateful to the people who are going to work every day and doing the essential things for us. And I thank you to everybody who's doing that.
And are you being impacted, Sara, in your work as well?
Yes, I also do a lot of in-person facilitation with town staff and citizens and big partner meetings, and we've shifted those online actually. So it's different, it's less fun, but the work's still getting done mostly by and large. There's a couple pictures of socially distanced, field masked, wheelbarrowing, building things, but so just to echo, we're lucky that we have, and our partners are too. People are pivoting and being really creative and trying to give space for, this public health emergency and keep doing good work.
That is just great. Well, listen, we're approaching the end of our time today, and I'd love to just do a go round here. Any of your final thoughts you'd like to share? What's your greatest hope for your work? Any last words? Why don't we start with Katie? Is that good? And we'll go around and maybe end with Alison.
Sure thing. I mean, I've been very grateful to be able to work with TNC for the last year and a half. I feel like I've made a lot of really great connections and learned a whole lot. I'm a coastal geologist by training. So I guess, yeah, I mean, I think just in terms of the greatest hope for my work is that I can contribute to a larger understanding and a larger knowledge base of restoration work and nature-based solutions to really kind of make the work happen that needs to happen for a more sustainable future.
Thank you. Sara.
Yeah, it's a great question. The thing that is really exciting to me and motivating to me about the Nature Conservancy is the systems thinking. So as we think about wastewater, it's great to be thinking about water is water and we need it to be clean. And as much as we can work on solutions that support all the uses that we have for water and try to solve problems at their root and not just play that expensive game of whack-a-mole that Alison was talking about, it makes me feel like very hopeful and very excited. So that's what I hope for this work.
And Alison, final thoughts.
Yeah, I imagine a world where people in nature thrive, and when everything, especially now, can feel like bad news, I try to really think about the future that I want, and I would encourage everybody to take the time to do that. Imagine the future that you want. As we learned from the Mill River restoration, which took 15 years, change is possible. Many of these important decisions are made at the local level. A lot of the questions that we've talked about today are things that can happen pretty locally, even though climate change is this huge problem. There's stuff that all of us can do. You can get involved with your local government to support nature-based solutions. You can make decisions on your own property about what you plant. Feel free to use us as a resource. We're here to help with that. And of course, every gift counts. Your donations make this cutting edge work possible. So thank you.
Thank you. And thank you all for joining us today. We really appreciate your support of the Nature Conservancy. It's your support that makes all of this work possible. We'll be sending everyone a follow-up email over the coming days with links to the resources we talked about today and a recording of this webinar. If you're enjoying these webinars, please share them with your friends, and you can follow us on social media at conserve_MA on Facebook and Instagram to keep up with our work and get updates on upcoming virtual opportunities to connect. We'll be off for the next 2 weeks, but we'll be starting back in January with the webinar for animal lovers on Thursday, the 7th of January at noon. We'll be speaking with Dr. David Wattles from the Massachusetts Division of Fisheries and Wildlife. Dave will talk about how the Mass Wildlife Team is working to protect moose and bear in Massachusetts, and he'll discuss how their habitat is being impacted by climate change and roads, as well as his ongoing research. We'll also dive into TNC's efforts to protect large and intact landscapes and wildlife connectivity with TNC forest ecology expert Andy Finton. As always, you can find the latest webinar schedule and register at nature.org/MA webinars. Thank you again so much for joining us, and have a great holiday. Bye now.
Thank you.